email server is kept on the internet protocol layers, and then on the application layer, in this case this LSA1 protocol, you only send the changes that happen in the incumbent side. There are two advantages of this procedure. One is that when nothing is changing, you do not have to send any messages. And the second is that in the case there is a change, the change is immediate compared to the other systems where you basically have to wait until the next request comes, and depending on the request cycle there might be different delays. Spectrum sensing for the protection of the incumbents has been specified for the TV white space in the US, although it's not much used there. CPRS, certain incumbents are fully protected only by spectrum sensing, and there's a combination of the database and the spectrum sensing use. LSA itself doesn't include spectrum sensing, but in the case of protection zone protection method, there's a possibility of extending the LSA protection zone with spectrum sensing. Horizontal interference management, meaning that so none of these systems have incumbent horizontal interference management. For CPRS, there is for the priority access, and then the license exempt use by default, it's very difficult to, it's not protected. In LSA, you do not need licensee horizontal interference management because there is just one licensee. But so having said that, we are actually collaborating at the moment with one European regulator to build together a system for wireless camera spectrum management in the LSA context. So outside the regulatory framework, it's still possible to do things that fit into the framework. Then one of the key issues, especially for the bigger operators, is that they do not want to disclose any of the topology information about their network. Also, on the incumbent side, it's obvious that military or public safety type of users cannot reveal what they have, and there might be some kind of obfuscation of the information, and depending on the system, it's easier or more difficult. On the licensee side, LSA provides exclusion zone and restriction zone methods where you can use actually the LSA system is kind of built so the spectrum management side, the geolocation database service is separated in two different parts. One is LSA repository, which is responsible of the incumbent side, and the LSA controller, which is responsible of the licensee side, so the mobile operator information, and then the information exchange between those has been minimized. With CPRS, you are basically able to do similar type of arrangement by using the hierarchy of the SAS systems, which is part of the specification. Then my kind of favorite topic is the rewarding spectrum management effort. So by default, any of the system when they are issued, so they probably work fine, but as we know, the technology develops. If all the rules and especially the protection algorithms have been put into the law and the regulation and written on the paper, then it's very difficult to change those. And there's no motivation for especially on the licensing side, there's an interest of having higher transmission power, so extending the area where they can use these frequencies, and they would be at some point of time ready to invest for the data, so they can get topographic data, they can get building height data, they can use ray tracing methods, or they can put sensors to see what is actually the power level that they are causing to towards the incumbent. And this is only possible if you are specifying the protection method by the protection zone. which is typically used, for example, for the as a coordination trigger between different countries, so that any radio system that is close to the border has to kind of be below the coordination trigger, or otherwise the national regulatory authorities in both countries have to begin the coordination process. Okay, so that was my introduction. Thank you.
Good afternoon, everybody. It's a pleasure to be here. I thought it'd be useful before I talk about two very quick examples of, I think, the next opportunities in dynamic spectrum access to actually define what we mean by DSA, as opposed to what I consider the old school paradigm when you have relatively passive technologies, exclusive markets, and licensed regulation, which often then lead to relatively limited use cases for end users. Dynamic access really, to me at least, involves three pretty fundamental elements. First, you have to have the adaptive technologies. And we've already talked a fair amount this afternoon about the use of geolocation databases and sensors, cognitive radios, and the like. These are all new advances in technology that were not really around 5, 10, 20 years ago. The second piece of that is a shared market, a place where not just one specific user exclusively has access to spectrum for a limited period of time, but in fact where two or more users or uses or applications can make use of those very same bandwidths, and by doing so create much greater efficiencies. And the third is a lightweight regulatory mechanism. Again, in the old school days, it was largely through exclusive licenses. Today we're talking about things like license by rule. We're talking about unlicensed uses, or sometimes lightweight, limited types of licensing requirements. These typically look more towards technical requirements rather than service or other types of requirements which were normally found in a licensed regime. So if you add these three components together, what you end up with are really an explosion of innovative applications, and Wi-Fi is certainly one great example, but only one of them, and many more are in the pipeline. I also want to stress this is not to say that the so-called old school approach is outmoded and should be done away with. Rather, these two approaches actually work quite well together in a very complementary fashion. In some cases, the exclusive licensing approach continues to make lots of sense to clear spectrum to allow for large geographic macro networks by exclusive providers. But more and more, we're seeing many of the newer applications that really rely on this mix of adaptive technologies, shared marketplaces, and the lightweight regulatory mechanisms. So two examples that I think just in the past year in the United States prove this out well. One is the 3.5 gigahertz proceeding at the FCC actually encompasses the 3550 to 3700 megahertz range. Here, basically, the FCC has freed up these bands for innovative uses for the first time using a so-called tripartite approach. One of the interesting elements of this is that the agency, rather than setting aside spectrum to be cleared of the incumbents and then at some point down the road allowing that spectrum to be available to a new set of users, in fact leaves the incumbents in place and thereby allows them to share that spectrum with another set of users. The Commission's approach, as I mentioned, is a tripartite. So the incumbents in this case are US Navy radars, mostly operating on the east and west coast of the United States. They would stay where they are, particularly in the 3550 to 3650, 100 megahertz range. They would maintain their existing status. The difference is that they would then share that spectrum on a basis, opportunistic basis, with other sets of users under what the Commission calls a citizen broadband radio service. In this approach, the priority access license, or PAL, would have the sort of the secondary use case, as it were, and then the general authorized access, or GAA, would be secondary to the secondary. So I think this is a really great example of creating a shared market structure and a lightweight regulatory approach, utilizing, as it turns out, the right kinds of adaptive technologies here, the Spectrum Access System Database, the SAS or SAS, which was originally put in place as part of the TV whitespace proceeding, and the Commission is now extending that for the first time outside those particular bands. So I believe this is really going to lead to a ton of innovative applications, some that we're already seeing that are being discussed, including mobile broadband. We're talking about small cell technology, smart grid, rural broadband, small cell backhaul, and many other kinds of point to multi-point networks. Most of those would not have been available or possible under the pre-existing sort of old school regime. So I think the FCC gets lots of credit for taking this on, and hopefully this model will be adapted and utilized in additional bands as well. The second example I would point to is the high frequency bands above 24 gigahertz. Now, these are normally the bands that folks would not have considered, again, in the old days, to have been of much use because of the propagation characteristics there, the atmospheric absorption. It's very difficult to have a traditional macro cell type mobile service or fixed service utilizing these bands. But given the new technologies in place, the FCC has recognized that there is now a new opportunity to relook at these bands and figure out whether they can free them up for some innovative applications. So the Commission actually launched a notice of inquiry back in October of 2014, and then just this past January, a notice of proposed rulemaking where they identify some specific bands for mobile use. In the 28, 37, and 39 gigahertz range, it's more or less looking at them for sort of commercial mobile networks in line with what we've seen, at least with traditional carriers. The area that's, I think, interesting to us at least is in the higher bands, the 64 to 71 gigahertz range. The Commission has proposed using the Part 15 operations there, essentially the unlicensed regime, and has talked about a number of different ways that those bands could be used, including for broadband over aerial platforms like high altitude balloons or unmanned vehicles, for field disturbance sensors, and for WiGig, the 802.11ad standard, which would potentially support backhaul transmissions and other types of applications there. So we think that's, again, a great example of where an agency has figured out that the technologies are now in place to allow a new type of market regime to go under a sort of lightweight regulatory process, which we believe will yield lots of really interesting and innovative applications in the near future. Thanks.
Thanks, Rick. So my name's Chris Wiesler. I'm with Facebook. And before I dive in here, I want to thank H for his leadership over the last few years. This is my 4th DSA Global Summit. And it's been terrific to kind of see this organization evolve and really kind of get the conversation on more flexible and creative ways to manage spectrum going around the world. And similarly, I'd like to thank Paul as well as our executive director. He was the one that sort of herded me into this group originally, and it's been really terrific for Facebook. So Facebook is about 2.5 years into an initiative that we call internet.org, and that's really just the name we give to our broad internet connectivity initiative. And essentially at the heart of that initiative, we are trying to understand and then address the fact that 20 years after the launch of the consumer web, there are still 4 billion people who are not online. To us, that says a couple things. Number one, it says the first 3.2 billion were the easy ones. And secondly, at least the approach we're taking is that it requires a deeper understanding of what those barriers to connectivity are. And we've seen some slides today about affordability. I thought those really did a great job, Richard's slides, to bring that affordability issue to life. And another big barrier out there is awareness. In many parts of the world, people just don't know what the internet is and how it can provide value or utility in their lives. And infrastructure is probably the third area that we would highlight as being a big barrier. And I think spectrum is that invisible infrastructure that perhaps is the most important infrastructure out there in terms of how it's managed and what it can enable, because those last 4 billion people are going to come online through some sort of a wireless connection. So, people can talk about a country's natural resources, and the reality is that every single country has the same spectrum resources. And a country's ability to maximize the utilization of that resource will really play a huge role in the citizens of that country experiencing the social and economic benefits of the internet. And we do believe that the world is going through this big transition from what's largely been resource-based economies to knowledge-based economies. So the benefits are getting even stronger to those communities that are getting connected. And I think that places a lot of pressure and responsibility on spectrum authorities to really think hard about the best way to maximize the utilization of that resource, that spectrum resource. So just a little story from this past fall and really the second half of last year. Facebook has got a number of different projects underway to address connectivity and address some of these hurdles. We founded a group called the Connectivity Lab, which sits within Facebook's infrastructure team. That team is fundamentally developing new access technologies as well as new network architectures with an eye towards more affordable and more pervasive connectivity. And one of the projects that is underway is an approach for providing backhaul using solar-powered aircraft, unmanned aircraft that can stay in the air for months at a time and beam internet connectivity down to fixed points on Earth. So those could be mobile operator base stations. They could also be Wi-Fi hotspots run by wireless ISPs, but it's a backhaul service. And when we looked at the spectrum that was already identified for use by high-altitude platform stations, which is, in ITU parlance, the category that we would fall into with the solar aircraft, we just didn't find enough spectrum to generate the kind of capacity we thought we'd need to from a single aircraft, and or there were technical or geographical limitations on that spectrum. So we suspected Google would have a similar interest in this, and we partnered up with Google to sponsor a future agenda item. And essentially, the goal was to identify a number of candidate bands of spectrum that we would study, and if we could prove that we wouldn't interfere with existing services, so largely fixed terrestrial and fixed satellite services, that at WRC 19 the radio regulations would get changed and these solar stratospheric platforms could utilize that capacity. So we went through we joined the ITU, we became members of the US delegation to the World Radio Conference. Combination of Google and Facebook employees and consultants traveled the world and kind of educated people on what we were trying to accomplish. And, we're doing this, just speaking for Facebook, we're doing this, in partnership with operators. The idea is to provide a backhaul service to enable connectivity in places that are completely unconnected, or to provide high capacity backhaul in places that are underserved, that might be 2G only, which is a very large percent of coverage that's out there in the world today. And so, we made it through the World Radio Conference, and we got this established as a future agenda item, and we're now engaging in technical studies to prove that the use of these candidate bands, which fall between the 20 and 40 gigahertz range, can be used without creating any harmful interference to existing services. But the experience, and let me say, I should have started out with this, we would not have been successful without the support of most of the telco authorities or the spectrum authorities in this room. The group from CTEL was incredibly supportive. I think actually it was Colombia that was the first one that signed on. And we came out of the CTEL meeting last summer in Ottawa with 12 countries supporting this. So that gave us very good momentum heading into Geneva. But the point I'd like to highlight, which is most relevant, I think, to today's discussion about dynamic spectrum, is that it was very, very difficult to get the right to simply study using some bands of spectrum for another use. And we've seen all of these charts, I guess today, Singapore, 6% utilization of their spectrum. Globally, it might be 9 or 10%. There is a tremendous amount of spectrum out there that has been assigned out for use that is underutilized. And if you go back to, if you believe in the big goal of maximizing the utilization of that resource, sharing has got to be the most fundamental aspect of how we think about spectrum management moving forward. It should be the default position that spectrum will be shared, and then let someone raise an objection and prove that it would create a problem, or let the proponents of sharing prove that they can coexist. But it was a real fight to make that happen, and we got through to the other end. There were plenty of other proposals that didn't. But I do think that in those fora around the world, whether it's sort of at the global level, at the ITU, or it's within a country, as a country discusses its spectrum policy and approach, I think that sharing has got to be an inherent part of, or an assumption on how spectrum is managed moving forward. So I'll leave it at that.
Glad to be here.